In the last lecture, we have seen row rank and column rank of the matrix. Next important part in our syllabus is the eigenvalue problem. Okay. The eigenvalue problem. Okay. This concept is also associated with our matrix. Okay. So this is also part of our first unit we are learning, that is matrices. Okay. We can find the eigenvalues of matrices. We will go to the concept of eigenvalues. Okay. Consider the linear equation Ax is equal to lambda x, where A is the n by n matrix. Say, okay, where A is some matrix, x is a some column vector. Okay, lambda is constant. Okay, so now what we will do? First, I will write what is the notation. So suppose A is equal to Aig. Okay, is our say n by n matrix. Okay, so x is equal to column vector, say x1, x2 up to xn. Okay, and this matrix when applies on this column vector, we get a new vector lambda into x. Okay, this equation is called characteristic equation. Okay, of the matrix. This equation is called characteristic equation. Characteristic equation. Okay. So now this equation can be written as A into x is equal to lambda into I into x, where I is a n by n identity matrix. We know identity matrix into any matrix. Now x is a matrix, column matrix. Okay, one column n row. We know identity matrix into any matrix x always equal to x. So Ix always equal to x. So Ax is equal to lambda Ix is same as Ax is equal to lambda x, because lambda x is same as lambda into identity into x, because identity matrix into any matrix is equal to that any matrix. So Ix always equal to x, since Rx is equal to x. Okay. Now transfer this to one side. Okay, so this lambda Ix minus Ax is equal to 0. Okay. Before going to the next step, I am saying that if we get a matrix and vector x such that Ax is equal to lambda times again x, then this lambda is called eigenvalue and this x is called eigenvector or characteristic vector. Okay. I will clear your idea after some explanation and when we will see one example. Okay. Now this equation can be written as this equation. Now here x is common. This implies this can be written as lambda into I minus A into x is equal to 0. Okay. Now we will put the value of matrices. Okay. Now lambda, this is lambda into identity matrix of n by n order. So identity matrix 1 0 0 0. Okay. Then 0 1 0 0. Okay. Similarly 0 0 up to 1. Okay. Then here 0 0 0. Okay. This is the identity matrix of order n by n. Only diagonal elements are 1, all other integers are 0. Minus A, where A is the n by n matrix. Okay, so first entry is say A11, A12 up to A1n, then A21, A22 up to A2n. Similarly here AN1, AN2 up to AN. Okay, into this column vector x or column matrix x, say x1, x2 up to xn. is equal to 0 vector. Okay, this is our equation. Okay, now what we will do, we will solve this. Now lambda into this matrix, we know we can multiply matrix by a scalar. When you multiply matrix by scalar, each entry you have to multiply that scalar. Now this entry 0, after multiplication also becomes 0. Only 1 into lambda is lambda, lambda into 1 is lambda. So diagonal entry will become lambda. So first entry is lambda, here first entry is a11, subtraction. We can take subtraction of matrix of same order. So here n by n order, here is n by n order. So you can take subtraction. Okay. This implies first entry is lambda into 1 lambda minus first entry is a11. A1. Second entry lambda into 0 is 0 minus second entry is a12. So my 0 minus a12. So minus a12 up to so on. Last entry was also equal to 0 minus a1 also minus a1 here. Okay. Then second entry lambda into 0 is 0 minus a21. So 0 minus a21. Then this entry lambda into 1 is lambda minus a22. So lambda minus a22 up to similarly minus a2 here. Continuing in this way, this entry is minus an1, then minus an2 up to so on. Diagonal entry lambda minus a11, lambda minus a22. So diagonal entries continue up to lambda minus an. Okay. After this subtraction we get this into this column vector x1, x2 up to xn is equal to 0 vector. This is the value of this equation, lambda I minus a into x is equal to 0. We can use this equation as a, this equation your name is 1, this is 2a say, okay, and this equation is 2d. Okay. Now this equation has this form. This is just another form of this equation. Now we know here is the matrix, here is the matrix is equal to 0. Always we know a into b is equal to 0 has a non-zero solution if only, okay, sorry, ax is equal to, if x is equal to 0, then this equation has a non-zero solution for x if only this matrix A, that is matrix coefficient matrix, has a determinant 0. Why? Because if determinant is not equal to 0, then A inverse exists. Okay, multiply both sides by A inverse. A into A inverse become identity matrix. So x into identity matrix is x, and here also multiply by A inverse. 0 into any matrix is 0. So we get x is equal to 0. So to get a non-zero solution, determinant of the coefficient matrix must be equal to 0. Okay. Here also, here is coefficient matrix, here is some vector is equal to 0. To get the non-zero values, to get a non-zero solution, determinant of this coefficient matrix, that is this matrix, must be equal to 0. This implies for non-zero solution, the determinant of the coefficient matrix, okay, determinant of coefficient matrix must be equal to 0. That is determinant of this matrix, that is determinant of lambda I minus a is equal to 0. Determinant of this coefficient matrix must be equal to 0. That is determinant of this matrix is equal to 0. And when we solve determinant, this is the n-bar matrix, so we get a polynomial. When we solve this determinant, we get a polynomial of degree n in lambda. Okay. When we solve this, taking determinant of this matrix equal to 0, we will solve this n-bar matrix and we will get a polynomial of degree n in lambda. Okay. This equation is called characteristic equation. Okay. And this polynomial has degree n, so it has n roots. We know any polynomial of degree n has at most n roots, so its roots are called eigenvalues. Okay, so its roots, this polynomial is of degree n, so its n roots. Okay, its n roots, say lambda 1, lambda 2, to lambda n are called eigen values. Okay. So this is the idea behind eigenvalues. This lambda is also eigenvalue. If we find the matrix A, so that Ax is equal to lambda x, then lambda is called eigenvalue. X is called corresponding eigenvector. Here, using this, we are dealing with this equation. The solution of the polynomial. Okay. So for matrix, when we ask to find determinant, so when we ask to find an eigenvalue, take this equation. This is the characteristic equation. Take determinant of lambda I minus a is equal to 0. Solve this equation, we will get the determinant is equal to some polynomial in lambda of degree n, and any polynomial of degree n has at most n root. This is polynomial in degree in root in a variable lambda. So we will get n roots in lambda. So lambda 1, lambda 2, lambda n. These are called the eigenvalues, or another name is characteristic root. Okay. This is called characteristic polynomial. Okay. This is called characteristic equation. This is called characteristic polynomial. These are called characteristic root or eigenvalues. This is called characteristic equation or what? Eigenvector. Okay. This is characteristic equation. This is characteristic polynomial. Okay. This is characteristic polynomial. This is characteristic equation. This is characteristic root. Now characteristic equation is also known as eigenvector. Okay. And the characteristic roots are called eigenvalues. Okay. This x is called characteristic vector, and these eigenvalues are called characteristic root. This is the characteristic equation. Okay. Now, I think you have got some small idea about the eigenvalues. When we will solve example, your idea will become more clear. Okay. We have seen the concept of eigenvalue and eigenvector. Okay. Now, to clear more idea, we will solve an example. Okay. So the question is, find the eigenvalues and the corresponding eigenvectors of the matrix. Okay. So we have to find eigenvalues. Now, keep in mind one thing: the order of matrix is 3 by 3. So the characteristic equation or characteristic polynomial is of degree 3. So this matrix, the roots of degree 3 polynomials are 3. So this polynomial will, this matrix will have 3 eigenvalues. Okay. Now, corresponding to each eigenvalue, there is always associated eigenvector. We know Ax is equal to lambda x. Then lambda is called eigenvalue, and x is called corresponding eigenvector. Okay. You have seen definition. X is equal to lambda x. This lambda is called eigenvector for eigenvalue, and this x is called corresponding eigenvector. Okay. Now we will solve this matrix. Okay, to find the eigenvalue. Okay. So how to find eigenvalues? We know to find the eigenvalue, we have to focus on characteristic equation of the matrix. What is the characteristic equation? The characteristic equation is determinant of lambda I minus a is equal to 0. Okay. This is the characteristic equation. Okay. Now we have to solve this equation to get the value of lambda. Okay. So this applies. Now lambda into I minus a. Here a is this matrix, and now here I is the 3 by 3 identity matrix 1 0 0 0 1 0 0 0 1. So lambda into I will be lambda 0 0 0 lambda 0 0 0 lambda. Okay. This applies determinant of lambda into I. So lambda is 0 0 0 lambda 0. Okay. Then 0 0 lambda. This matrix is our lambda into I. Okay. Because I is 1 0 0 0 1 0 0 0 1, and they are multiplying by lambda. So lambda into 1 is lambda, lambda into 1 is lambda, lambda into 1 is lambda. All other entries are 0, so lambda into 0 is 0. Okay. This is lambda I minus a. A is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Determinant equal to 0. Now we will take the subtraction. Okay, this implies determinant of now lambda minus minus 2, that is lambda plus 2. Okay, so lambda plus 2. Then 0 minus 2, so minus 2. Then 0 minus minus 3, so plus 3. Okay. Then 0 minus 2, that is minus 2. Lambda minus 1, so lambda minus 1. 0 minus minus 6, so plus 6. Okay. 0 minus minus 1, so plus 1. Okay. Then 0 minus minus 2, so plus 2. Okay. Then lambda minus 0, so only lambda. Okay. Is equal to 0. Determinant of lambda I minus a is equal to 0. So determinant of this is lambda I minus a. When determinant is equated to 0. Okay. Now solve this matrix. I have explained in the theoretical concept we have get a n by n matrix lambda I minus a, and I have told you that when you solve for determinant you will get the polynomial of degree n for n by matrix. Now we here 3 by 3 matrix, so we will get polynomial of degree 3 by solving this determinant. Okay. Now you look at the solution. Now we know how to calculate determinant of the 3 by 3 matrix. Okay. So determinant is equal to, so first term as it is, that is lambda plus 2 into what? Lambda minus 1 into lambda. So lambda into lambda minus 1 minus 6 into 2, so minus 12. Okay. Now we take minus of this. Okay. So minus minus plus, so plus 2 into minus 2 lambda minus 6 minus 2 lambda minus 6. Okay. Understand? Minus of minus plus 2 minus 2 into lambda minus 2 minus 6 into 1, that is minus 6 plus 3 into, okay, plus 3 into 2 into minus 2 minus 4. Okay. So minus 4 minus 1 into lambda minus 1, that is minus of lambda minus 1, that is minus lambda plus 1. So minus, it's minus 4 as it is, minus lambda plus 1. So what we have done? We have just taken the determinant of the matrix and is equal to 0. Now solve this equation. Okay. So lambda plus 2 as it is, this lambda into lambda is lambda square, lambda into minus 1 is minus lambda. Okay. Then this is multiplication is over. Now this is minus 12 as it is. Then 2 into minus lambda is minus 4 lambda. 2 into minus 6 is minus 12. Okay. Then 3 into minus 4 is minus 12. Then before that we can do one thing. Minus 4 plus 1 is minus 3. 3 into minus 3 is minus 9. And 3 into minus lambda minus 3 lambda equal to 0. Okay. Now you have to multiply these two brackets. So first I will multiply by lambda. So lambda into lambda squared is lambda cube. Lambda into minus lambda is minus lambda squared. Lambda into minus 12 is minus 12 lambda. Okay. Minus lambda squared minus 12 lambda. Okay. Then plus 2 into lambda squared. So 2 lambda squared. 2 into minus lambda, so minus 2 lambda. 2 into minus 12 minus 24. Okay. Now this minus 4 lambda as it is, minus 12 as it is. Okay, this minus 12 as it is. So minus 12 minus 9, which is minus 21. Minus 12 minus 9. Okay. Then minus 3 lambda is equal to 0. Again we will simplify this. Now there is only one term in this equation of lambda cube. Okay. So first term is lambda cube. Now see, we are getting a polynomial in lambda of degree 3. I have told if matrix is of order n, you will get polynomial in of degree n. If matrix is of order 3 by 3, you get a polynomial of degree 3. So we are getting characteristic polynomial. Okay. So this is lambda cube. Now Here is minus lambda square. Okay, this is minus lambda square plus 2 lambda square. So there are two terms of lambda square. So 2 lambda square minus lambda square is plus lambda square. Okay, there is no other term of lambda square. Okay, then this is minus 12 lambda. Okay, minus 2 lambda, minus 4 lambda, and minus 3 lambda. So minus 12, minus 2, minus 14, minus 18, minus 21, minus 21 lambda, and at last this is minus 24. Okay, and this is minus 21. So this is equal to 45. Okay, so minus 45, minus 45 equal to 0. Okay, so we get a polynomial of degree 3. Okay, so this is our characteristic polynomial. Now this is polynomial of degree 3, so its roots are the eigenvalues of this matrix, and we will get 3 roots. Okay, so these 3 values will be eigenvalues of the matrix. Okay, so we will solve this polynomial to get the eigenvalues. Okay, so first by observation we will try to put values 1, 2, 3, 4, 5 to check whether these are the roots or not, because here polynomial of degree 3, so we have to find 3 roots. Okay, if you put lambda is equal to 1, then 1 cube is 1. Okay, 1 cube is 1, 1 square is 1. So minus 21 into 1 is minus 21 and minus 45. Now 1 plus 1 is 2, minus 20 and minus 45 is not equal to 0. We know if something is the roots of this polynomial, then by putting the value we will get our solution. You put lambda is equal to 2, so 2 cube is 8. Okay, so 2 cube is 8, then 2 square is 4, then 2 into 21 is 42 minus 45. Again 8 plus 4 is 12, minus 42 minus 41. No, again not equal to 0. Try to put lambda is equal to 3, lambda is equal to 4. Okay, you will not get a solution. Now try to put lambda is equal to minus 1. Okay, lambda is equal to minus 1. Put. So when we put lambda is equal to minus 1 cube is minus 1. Okay, then minus 1 square is plus 1, minus 21 minus 1. So plus 21 minus 45. Again 21 plus 2 is 22, minus 1 minus 45 is minus 46, plus 22 minus 46 not equal to 0. Now put minus 2. Okay, put lambda is equal to minus 2. Then we get minus 2 cube is minus 8, minus 2 square is plus 4, then minus 2 minus 21, so plus 42 and minus 45. Now 42 plus 4 is 46 and minus 8 minus 45 is minus 53, again not equal to 0. Minus 2 is also not the root. Okay, now put lambda is equal to minus 3. Okay, so minus 3 cube is minus 27. Okay, then minus 3 square is plus 9, then minus 21 minus 3, so plus 63 minus 45 as it is. Okay, now 63 plus 9, so 72 plus 72. Okay, and minus 45 minus 27. Okay, what is value? 45, then plus 27, so 55, 65 plus 7, that is 72. So 72 minus 72 is equal to 0. So lambda is equal to minus 3 is the one root of this polynomial. Now we will find other two roots by synthetic division. Okay, you got the idea how we find first root? We have already put lambda is equal to plus minus 1, plus minus 2, plus minus 3. Okay, when we put lambda is equal to minus 3, the answer is getting 0. This implies lambda is equal to minus 3 is one root of this equation. So we will find other roots by using synthetic division. Okay, so lambda is equal to minus 3 is one root. So lambda is equal to minus 3 is the eigenvalue of this one eigenvalue of this matrix. Remaining two eigenvalues we will find later. Okay. So this is one eigenvalue. Okay. So other eigenvalue we will find by synthetic division. Take the coefficient of this polynomial. The coefficient of lambda cube is 1. Coefficient of lambda square is 1. Coefficient of lambda is minus 21. Okay. And the coefficient of this is as it is minus 45 as it is. Okay. Then minus 3 is one root, so I have taken minus 3 here. Okay. So this one as it is. Minus 3 into 1 minus 3. 1 minus 3 minus 2. Minus 3 minus 2 is plus 6. Minus 21 plus 6 is minus 50. Minus 15 into minus 3 plus 45. Minus 45 plus 45 0. Okay. So this polynomial is equal to one factor is minus 3. So this polynomial is equal to lambda plus 3. That is lambda minus 3. So lambda plus 3 into from this 1 into lambda square minus 2 into lambda minus 15. So we have taken factorization of this polynomial. Now we can solve this secondary polynomial easily to find the other root. You know the method to find the to solve the equation of degree 2. Okay. Use your methods, basic method to find the roots of quadratic equation. Okay. You will get one value lambda is equal to 5 and lambda is equal to minus 3 and this lambda is equal to again minus 3. So these are the three eigenvalues of this matrix. Okay. You can verify that 5 is the root by putting 5. 5 square is 25. Okay. 25 minus 2 into 5 minus 10 is minus 15 as it is. 25 minus 10, 50 minus 15, 0. You can again check minus 3 also roots. So the roots of above polynomial or above equation are lambda 1 is equal to, you can say minus 3, lambda 2 also equal to, you can say minus 3, okay, not 3, minus 3 and lambda 3 is equal to 5. You can give name 1 to 3 to any value. So roots are 3 minus 3 minus 3, okay, minus 3 and 5. So minus 3 5 are the eigenvalues of this matrix A. Why? Because these are the roots of this characteristic polynomial. The roots are called eigenvalues or characteristic roots. So these are the eigenvalues of this matrix, and you can verify. Okay, what you can verify? You can verify that this using this value minus 3, you can solve the equation Ax is equal to lambda x. Put lambda is equal to minus 3. Okay, but what we can do about x? X is the eigenvector, and in this lecture you are just find the method to calculate eigenvalue. How to calculate eigenvector we will see it in next lecture. Okay, so up to this keep in mind how to find eigenvalues. Eigenvalues of this matrix are minus 3, 5. How we get these eigenvalues? By solving this equation. This is the characteristic equation. Determinant of lambda I minus a is equal to 0. We have solved this matrix. We have solved this determinant, and we get this equation. We get this polynomial. We have find the roots of this equation, and we get the three roots minus 3, and 5. So these three roots are the three eigenvalues of the matrix. In next lecture, we will find eigenvectors. We know corresponding to every eigenvalue, this is always a eigenvector. So how to find eigenvector, we will focus on it in next lecture. Okay. So thank you.